Hello everyone. Today I am starting a new playlist on Docker. In this video, we will get ourselves introduced with Docker. This is the first video in this series, but I have planned to create a complete playlist on it, which will help you learn Docker in easy way. Now let us think about an scenario. Developer team developed an application and passed it to testing team. Testing team started complaining that application is not getting installed in their system, so there might be issue with the code developed by development team. Since development team had developed it and tested it in their own environment, they didn't have any clue what went wrong. After a combined troubleshooting session between both the team, it was concluded that some binary and library files were missing at tester team, so they were not able to install the application developed by development team. Every time testing team had to perform any testing, they first need to download all those binary and library files which is required to run that application. Here comes in the concept of containerization. Docker is a tool designed to make it easier to create, deploy and run application by using containers. Containers allow developer to package up an application with all the part it needs such as library and other dependency file and ship it out as a package. So if we are developing an application and wrapping it up in a container, there won't be any platform dependency to run that application. Now let us understand the difference between container and a virtual machine. In the left side of the diagram, we can see an operating system is installed on the server and a container runtime, which is Docker in our case, is running on this operating system. So different applications are running in form of a container in this system. These applications are using resources from operating system. By resources, we mean CPU, memory, etc. These resources are not fixed to any of the application. Let's say if application 1 requires more CPU and more memory, and at that time application 2 is idle, so more of the resources will be allocated to that container. Since only one base operating system is there and the rest of the containers contain only binary and library files, these containers are of lightweight. Coming to virtual machine, let us have a look at the right side of the diagram. Here one server will be there and on top of that server a virtualization software is installed, here Hyper-V in our case. On top of that two VM is created, VM1 and VM2. These virtual machines are having fixed amount of resources such as memory and CPU from the server. So if we are running any application on this virtual machine, and even if that application does not require that much amount of resources which is allocated to that virtual machine, it won't be in free state. It means, let's say the base server has total 16 GB of memory and these two virtual machines are created having 4 GB of RAM each. If some application is running on virtual machine 1 and it requires, let's say, 5 GB of RAM, it won't run because that virtual machine itself has only 4 GB of RAM. But this was not the case of container. If some container requires more resources, it can easily get from its base operating system. Also, in case of container, if we want to decommission an application, we simply need to delete that container. But if but in case of virtual machine, if we want to decommission an application, either we have to delete that application and decommission that virtual machine, or delete that application and delete all the files which are related to that application in that virtual machine. So this is a cumbersome task. That's why we moved from virtual machine to containers. Now let's understand the architecture of Docker. Docker consists of three things: Docker daemon, REST API, and Docker CLI. The system on which Docker is installed is called Docker host. Let's say if you have a system where Docker is installed, then your machine itself will be called as Docker host. It is the house of all the containers which is running on that Docker. Coming to its first component, that is Docker daemon. It is something which we actually install on the Docker host. When we say we are installing Docker, it means we are installing Docker daemon. Then comes Docker CLI. It is the interface which is front-end to the user. User interact with the Docker daemon with the help of Docker CLI. REST API is in between of Docker CLI and Docker daemon. User can't directly write instructions in CLI or Docker daemon. Instructions which are given to the CLI are passed through API calls with the help of REST API. This is the basic architecture of Docker. In next video, we will launch a container having Jenkins running in it. I hope this video was informative. We'll see you in another video. Till then, happy learning.